Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss functions having arbitrary period. How that is change of interval in that of Fourier series. Let's begin. Till now, we studied regarding the functions with the period of 2 pi, but in many cases the period changed to 2c, whereas c is any positive real values. In electrical engineering, some problems are the presence of the function not always 2 pi, but that is t, or we can say 2c, where c is any positive real values. So this period must be converted to the length of 2 pi. The independent variable x is also be changed proportionally. That's why let the function f of x be defined in the interval minus c to c, where c is any positive real number. Now we want to change the function to the period of 2 pi. Since it is in that of the period of 2c, but here our aim is to change that particular function f of x to that of period of 2 pi. As we change to that of period of 2 pi, then we can easily evaluate the Fourier coefficients like an and bn. So how we done to that of period of 2 pi? How to change? 2c is the interval for variable x, as 1 is the interval for variable as x by 2c. Hence for 2 pi we have to change the function to the period of 2 pi. For 2 pi is the interval for variable will be x by 2c into 2 pi, that is pi x by c. So we have to put pi x by c, so that let we put z is equal to pi x by c, or we can say x is equal to zc by pi. Thus the function f of x of period 2c transformed to the function f of cz divided by pi, or we can say it as capital F of z of period 2 pi. Now we change that of function of period 2c to that of function in terms of c to that of period 2 pi, sorry, in the period of 2 pi. Now that function f of z can be explained, can be expanded in Fourier series. How we expand that function? Therefore f of z is equal to, that is f of cz by pi, cz by pi is equal to a naught by 2 plus summation over n is equal to 1 to infinity a n cos nz plus b n sin nz, where the coefficients as a naught is equal to 1 by pi integration from 0 to 2 pi f of z dz, that is equal to 1 by pi integration from 0 to 2 pi in place of f of z, that is f of cz by pi dz. Now we put z is equal to pi x by c. Then what happened? Also the limits are changed to 0 to 2c. Here 1 by pi is equal to 0 to 2c, that is f of x cz by pi, that is x, that is f of x, differentiating that term, that is d of z, that is d of pi x by c. When we differentiate that term, that will be pi by c as constant to that of outside, therefore it will be 1 by c integration from 0 to 2c f of x dx, the value of a naught. Now another Fourier coefficient a n, therefore a n is equal to 1 by pi integration from 0 to 2 pi f of z cos nz dz is equal to 1 by pi integration of 0 to 2 pi, that is f of cz by pi cos nz dz. Now we put here z is equal to pi x by c. Then it will be 1 by pi. Again the limit change to 0 to c, that is f of x cos n pi x by c, that is d of pi x by c, differentiating that term and the constant to that of outside, that will be 1 by c integration from 0 to 2c f of x cos n pi x by c dx, that is an another Fourier coefficients. Similarly, the value of a Bn will be 1 by c integration from 0 to 2c f of x sin n pi x by c dx. In this way, we can easily find the Fourier series of that of given function, as it has arbitrary period. That means we change that of interval. That interval is in terms of minus c and c. We change it to that of interval of 2 pi, and then for transforming that of Fourier series and determine the Fourier coefficient a naught, a n and b n for that of arbitrary period. Now take an example regarding this particular situation. Here the question is, find the Fourier series of f of x is equal to 0, that is from minus 5 to 0, and the function is 3 when that value from that of 0 to 5. Look that of particular condition, that the range is from minus 5 to 5. Here minus 5 to 5, that is 2c is equal to 10. How we get that of solution? Here 2c is equal to 10, which implies c is equal to 5, since its range from minus 5 to 5. So Fourier expansion of that of function, Fourier expansion of that function f of x is given by, that is f of x is equal to a naught by 2 plus summation over n is equal to 1 to infinity a n cos n pi x by 5 plus summation over n is equal to 1 to infinity bn sin n pi x by 5. Now we have to calculate the Fourier coefficients, where a naught is equal to 1 by c, that is 5, integration from minus 5 to 5 f of x dx is equal to 1 by 5 integration from minus 5 to 0 f of x dx plus 5 to 0 f of x dx minus 5 to 0, 0 to 5. We change to that of limit minus 5 to 0, again sorry, that is 0 to 5, 0 to 5. Okay, that will be 1 by 5 integration from 5 to 0 change to that of, that will be 0 dx, 0 dx minus 5 to 0, f of x is 0 in that of particular interval, plus 0 to 5 3 dx, from 0 to 5 that value is 3, that is 3 by 5 x from 0 to 5, that is 5 cancel out, the result is 3, that is the value of a naught. A naught is 3. Then we have to calculate an and bn. For an is equal to 1 by 5 integration from minus 5 to 5 f of x cos n pi x divided by 5 dx is equal to 1 by 5 change, that is minus 5 to 0 f of x cos n pi x by 5 dx plus 0 to 5 f of x cos n pi x by 5 dx is equal to 1 by 5 in that of interval, the result is 0. Here minus 5 to 5, 0 cos n pi x by 5 dx plus 0 to 5 in that interval f of x 3, 3 cos n pi x by 5 dx is equal to, here 3 by 5 integration over 0 to 5 cos n pi x by 5 dx, that is 3 by 5, that is sin n pi x by 5 divided by n pi by 5 from that of limit 0 to 5 is equal to 3 by 5 into 5 by n pi, that term. Putting the upper limit and lower limit, the value will be sin n pi 5 by 5 minus sin 0, that is equal to sin of n pi, that is 0, that term is 0, which implies a n is equal to 0. Again another coefficient, that is bn. Bn is equal to 1 by 5 integration from minus 5 to 5 f of x cos sin n pi x by 5 dx, that is 1 by 5, we change that of limit minus 5 to 0 f of x sin n pi x by 5 dx plus, that is 0 to 5 f of x sin n pi x by 5 dx. Here f of x is 0 in that of region, only that term exists, therefore that is 1 by 5, 0 to 5, that is f of x value will be 3 here, that means 3 to that of side only, sin n pi 5 by 5 dx is equal to 3 by 5, again the integration of that term, that is 5 by n pi, here minus cos n pi x by 5 to that of limit 0 to 5, that will be 3 by 5 into 5 by n pi, and using upper limit and lower limit, that will be minus cos n pi 5 by 5 plus cos 0, that is 5 cancel out, cos 0 is equal to 1, 5 cancel out, that is 3 by n pi, 3 by n pi 1 minus cos n pi, cos 0 is equal to 1, therefore here we have Bn is equal to 3 by n pi, that is 1 minus cos n pi. Now 3 Fourier coefficients, that is a naught is equal to 0, an is equal to 0 only, Bn term exists, therefore we expand that of given function in terms of that of Fourier series, therefore the Fourier expansion is given as, we put its values, therefore f of x is equal to, here a naught by 2, here a naught is equal to 3, that is 3 by 2 plus an is equal to 0, that's why this total term will be 0, plus in that of case Bn exists, that is summation over n is equal to 1 to infinity 3 by n pi 1 minus cos n pi, that is the value of Bn, then sin n pi x by 5. Now we have to expand that series, which implies f of x is equal to 3 by 2 plus summation over n is equal to 1 to infinity 1 minus cos n pi by n pi into sin n pi x by 5. Just rearrange it. This is the Fourier expansion of that of given function f of x equal to 0 in that of interval and 3 in that of interval. We proceed in this way and finally get the result. So with the help of this video lecture, we understand how the functions having arbitrary period, that is change of interval, will be takes place in case of that of Fourier series. That is the expansion of that of Fourier series, where a naught, a n and Bn are evaluated, and take an example regarding this. putting all these values we found that thing. So, with this useful and informative notes, let me wind up this session. Thank you.